let's kick it. Ice, baby. Collaborate and listen to my applied forces coming right at you. Flowing right at you, yo. It's going to be one dope I almost said lesson. You tell me. Alright, applied forces. Can there be anything cooler than this? This is like amazing stuff, applied forces. Oh yeah, got the bling on. Got a little bling going. Got my bling bling. Bling bling. We're ready to roll. Rock and roll. I don't even have oh man, this was supposed to be a highlighter, man. Applied forces, kids. That's what we're doing today, yo. I brought my alter ego out. Oh yeah. Alter ego. Ready to rock and roll. See, what I'm going to do is I'm going to take a thing. I don't know what it is. Just a thing. Call it a thing. I'm going to apply a force to it. I'm going to push it this direction. Shit. Push it in the easterly direction, yo. Maybe like 100 pounds per square inch. I don't know if that's right, yo. But it's good. And then my buddy comes by and he starts pushing. And he pushes in this direction with a force of like 50 pounds. How am I going to solve this problem? Well, clearly it's not going in my direction. And clearly it ain't going in his direction, yo. So it's got to be going in like this direction. Somewhere ding, 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 ding out in this direction. Well, when we're dealing with forces, yo, that's called the resultant. And when we're working with the resultant, man, I just done got rid of my force. Man, problem can't be done without the force. When I'm working with resultants, at least in our mathematics, in our small little world, what we're going to be doing, yo, we're going to be doing a little, we're going to draw it into a parallelogram. Because parallelograms are kind of cool. Kind of fun, those shapes. Got four sides. Got lots of angles. Let's talk about parallelograms. Let's see what you remember from last year. Yo. Let's say I gave you that the angle between our two forces is something like 50. Could you tell me what this is? Oh, I think you could. Couldn't you? That would be like 130. Because you know that in a parallelogram, that any two consecutive sides add up to 180 degrees. Yo. Alright, let's talk about that. Let's say, oh, could you also tell me that this was 50? Because opposite angles are congruent as well in a parallelogram. See what I'm saying? Oh, yeah. Alright, let's get rid of that stuff. Let's see if we can figure out some other stuff. Lost my parallelogram. Let's draw that. I'm going to draw that in with a different color. So you know that my original two forces were right there. Alright, there we go, yo. Alright. Now, what if I drew this resultant in? That'd be the resultant. Him pushing, me pushing, we're pushing in this direction. Right? That'd be the direction it'd go. A little bit to the east, a little bit to the north, kind of in the, you know, I'm pushing harder than he is, so it will go off generally into that direction. Alright, kids. This is annoying. It's got to go. Don't know where it is. Hopefully I can get it off. Oh, I might have to wear this tomorrow. Yo, the bling. Got to get it off. And this hat, kind of annoying. But the earring, it's got to stay. Mostly because I don't know how to get it out. No, I do, but I don't want to. Okay, so let's talk about angles then. Let's see. If this angle right here, see this here would be a line, right? This angle right here, since I know a little bit about parallelograms, this side and this bottom side are parallel, and this side would be a transversal, then wouldn't these be alternate interior angles? So therefore, if this is 30 degrees, wouldn't this also be 30 degrees? And let's just say for fun, this was 20 degrees. Wouldn't this be 20 degrees? Because alternate and interior angles are congruent. Man. And the other thing I know is if this force is 50, I can bring it over here and 50 because opposite sides of a parallelogram are congruent. So what we're going to do is we're going to either use the law of sines or the law of cosines to solve force questions. These applied force questions. They're not that difficult. A little bit complicated, but you'll be able to hang with me. Yo. Got to find my calculator. Forgot to get that up. Give me a second. Ka-ching. There it is. It'll be up in a second. Annoying us probably. Don't know where my notes are. Come on, we'll get down. There we go. All right. Oh, that's not what I want. I want this. All right, so let's talk about this. Let's see. All right, we got to draw. Now, anytime you say, I got a little force going this way and a little force going this way, you got to draw a parallelogram. Here's the way it's going to work. We'll start over here. We're going to have a force going in this direction and a force going in this direction. They're acting at a body, on a body. I don't know whose body. Somebody. Somebody. Oh my gosh, that's kind of funny. All right, so normally what I'll do is I'll make one longer and I'll make one shorter. So it would make sense to put a 12 here and a 20 here. Now let me finish out the parallelogram, trying to draw as best a parallelogram as possible. They act on a body with a angle of 60 degrees. Well, since I put this 60 degrees here, while I'm here, I might as well put what here? Come on, give it to me. Good, 120. And they will create a resultant force that will come in a diagonal across this parallelogram. And the question says, is find the nearest pound the magnitude of the resultant. So that's what we're going to find. We're going to find the magnitude. Why do I keep doing that? Magnitude of the resultant. All right, so let's see what I got here. I got this as 12, so I know that this is 12. I'm looking for this. I'll call it X, and its angle across it, I'll just call X. Well, if you remember from yesterday, we got side, angle, side. Side, angle, side screams. Remember, S and SAS. S and SAS. They scream for law of cosines. So that's what we're going to do. We're going to do X squared. I'll just call the other ones A and B just for fun. A squared plus B squared minus 2AB cosine X. Don't forget, beginnings and the ends still have to match. Still like putting on my vanilla ice back on. That was fun. All right. Don't know what S is. Just type this in. X squared equals. A squared is going to be this 12. I'll call it 12 squared. Plus B squared, which will be this 20 squared. Minus 2 times 12 times 20 cosine of 120 degrees. Well, this is great. Everything's on the right side. Makes my life really, really easy. All I got to do is go over to my calculator, which does not appear to be up for some reason. Let's see what's going on. There it is. Let's minimize this. I don't know why that didn't come up. Let me go back and forth between my OneNote. Oh, that's not it. Yeah, there's my OneNote. All right. So we'll get on the calculator. We'll type it in. Let's see what we got here. We got 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 120 degrees. Press enter. 784. Bring that back over to my work. Having a hard time getting back to my work. This one. All right, so I have X squared equals, what was that again? There it is, 784. 784. Well, to get the answer then, I have to take the square root of that. And I'll just do the square root of the answer. Oops, what do I got that for? Escape. Control square root of the control answer, and I get 28. So my answer is 28. Boom, that's it. X equals 28. I'm not going to use the calculator too much. I'll do it a couple of times, but then I'm going to stop using it. All right. If two forces of 30 pounds and 40 pounds act on a body with an angle between them of 120 degrees. You know what? Even though I know that this isn't the exact diagram of what's going on, I always like to just draw a parallelogram when I get these forces question. And I'll write 120 in there. Even though not even close to 120, that's okay. It doesn't matter. I know the resultant's going to go here. I know that this is going to be my 30, my smaller, and this will be my 40, my larger. What's it asking for? Again, we're asking for the magnitude of the resultant. So it's going to be basically the exact same work that we just did. So let me get a different color in here. Get a little green, little Christmas colors. X squared. X And we'll call this angle x down here just to make my life a little bit easier. Don't forget to bring this 30 over here so we can do it. And I get x squared equals, and since it's the exact same as the last one, I'll just write it in. 30 squared plus 40 squared minus 2 times 30 times 40 times cosine of 60. Well, the nice thing about cosine of 60, it's just a half. So that means this is going to turn out to be a nice number. We'll get 1200. In order to find the final x, we have to take the square root of both sides. And when I take the square root, I get x equals 6401, whatever. X equals, makes actually a difference in this case because they said rounded, and oh no, it doesn't. It says rounded to the nearest pound, so my answer is just 35. Boom. Ka-ching! I'm done. Moving on. Next page. We're only going to do 5. Practice was 5. I'll give you the answers to the other ones. Hopefully they're right. All right, 2 forces act on a body such that the resultant is 50 pounds. This time they're going to change things up a little bit. They're actually going to give us the resultant. So I'll draw that in. Ka-ching. And it's 50. Man, I think I lost my voice there. Not 50 degrees, it's just 50. 50. Now, hold on. The measure of the angles between the resultant and the forces are 25 and 38. Well, since this one's smaller, I'll put 25 here. I mean, if I can make it make sense, I'll try to make it make sense. 38 degrees. And while I'm at it then, don't I know this to be 38 degrees? Because they're alternate interior angles. And this one to be 25 degrees. And now let me keep with this same theme here. I know this angle. If I add those two up, that's 50 and 13 makes 63. There's 63 degrees here. That means I just define this angle. I subtract from 180. 180 minus 53 is 117. Sorry, I thought I was at the bottom of the page, not the top. 117. All right, let's see what they're asking for. We want to find the nearest pound, the magnitude of the larger applied force. All right, so the larger applied force would be here. I'm going to call this x. Now, the angle opposite this would be here. We'll call this x. And so I want to find this x. I want to find this side right here. Let's see what I got here. I know this angle, and I know that angle, and I know that side. I have one side and one side only. If I only have one side, we remember from yesterday that I'm going to use law of cosines. If I have side, 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 or sas. I only have one side. I'm only given one side. So there's no way I can go through and try and even attempt this with the law of cosines. I'm going to have to go back to the law of sines. X over the sine of 38 equals, what do I know? 50 over the sine of 117. Law of sines. It's angle, angle, side is what I really have. Or angle, side, angle. If you want to do it angle, side, angle, I have angle, side, angle. Or I have angle, angle, side. It doesn't matter. The fact of the matter is I only have one side, and you're not going to do the law of cosines with just one side. So let's see what we got here. Let's cross multiply. We'll get x times the sine of 117 is equal to 50 times the sine of 38. I need to get x by itself, so I'll divide by sine of 117. Ka-ching, ka-ching. And quite honestly, you're just going to type this in your calculator. I'm going to save us some time. I typed it in. You get 34.54. 34.54. 8651. 8651. And we want to the nearest pound. So my answer is 35 pounds. There's my answer. Woo! Yo. My earring's starting to bother me. My mom called. She wants her earring back. Ah! That's hilarious. I knew you were thinking that, Pitt. Got 8 pounds and 12 pounds acting on a body. We're given the magnitude as 15 pounds. Find to the nearest degree The angle between the resultant and the larger force. So let's go to town on this thing. It's our parallelogram. We'll do our parallelogram in. Draw. That's not very good. We'll draw in our resultant, which is just the diagonal of this thing. And let's put in everything we know. We know this is 8. I know this is 8. I know this is 12. I know this is 12. I know the resultant is 15. We have side, side, side. And we want to find an angle. And anytime you have side, 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 you're going to use the law of cosines. Now, let's see what I'm looking for. I want the angle that's opposite the larger force. So I want this angle. Remember, since this is 8 degrees, and this is 8 pounds, and this is 12 pounds, or this force is larger, the angle opposite over here will be larger. So I'll call this x. And then we'll call this x. And just for fun. So I'll do x squared equals, let's see how we're going to do this. A squared plus b squared minus 2ab cosine x. You want to use C and C? I don't really care. It doesn't matter. I don't have the thing labeled that well anyway. What I want to do is know what side am I using and what angle I'm going to use these two. I'm going to use these two, and they should be on the outsides. But since I need to look for this, we need to isolate this. So we're going to do x squared minus a squared minus b squared all over negative 2ab. Equals that's an interesting problem. Equals cosine of x. So cosine of x is equal to that. All right, let's see what we got now. Let's see. Let's start plugging stuff in. X squared, we'll put the larger one in there. That's going to be 12. So that's 12 squared minus that's interesting. 12 squared minus, what are we doing? 8 squared minus 15 squared all over negative 2 times 8 times 15 equals cosine of x. So cosine of x is equal to, I'm going to type this in. I don't know what this is. So we'll do control division, get our fraction. And then we're going to do 12 squared minus 8 squared minus 15 squared all over negative 2 times 8 times 15. And we get 29 over 48. So this is equal to 29 over 48. And now to find out what x is, I got to do inverse cosine of this mess. 29 over 48. All right, that's no problem. So inverse cosine of the answer. And that makes it easier. 52.83 degrees. So x equals 52.83. All right, so this thing's really bothering me, so I got to get rid of it. I think that'll help me. And that's bothering me. Let's get that on. All right, so we're going to go back and forth, and I don't need this open. I might as well get rid of that because that's bothering me too. Everything's bothering me today. We're going to do just this and this. That's all we need. Man, there we go. Do I need any more than that? So what does it say? Rounded to the nearest degree. So our answer is x equals 53 degrees. There it is, kids. All she wrote. Man, that was not hard at all. Moving. Find to the nearest measure the angle between two applied forces if the resultant force is 14 pounds. So this one said it wanted between the resultant and the larger force. So it just wanted this little angle in here. This one's going to be a little bit different. This one's a little bit trickier. Watch how this one goes into play. So we're going to draw in our first forces and finish our parallelogram just like we have always. I'll draw in my resultant. And then let me pick a different color. It says that we have 9 pounds, 11 pounds, and 14 pounds. And let me just finish this 11 and 9. And the question says, find to the nearest degree the measure between the two applied forces. So I really want to find this angle right here. That's kind of hard to do. It's almost impossible to do. So what we're going to do actually is find this angle. And I think when we're done with this problem, you'll see why we're going to find this angle. Notice in this triangle right here, I have side, side, side. Since I want to use this angle, I'll call this x and I'll call this x. So I'll do x squared equals a squared plus b squared minus a 2ab cosine c. I'm not huge on labeling all these things. I mean, I think you can figure out that the two things that you're working with have to go on the opposite ends. That's not too bad. But since I want to solve for, since I really want to get this by itself, I'm going to isolate that by moving everything over to the other side. So I'll get x squared minus a squared minus b squared all over negative 2ab. Now, if you haven't listened to the law of cosines video yet, then I go into more of an explanation of why I do this, and I do it a little bit slower for you. But for today, since I think you've already gone through that lesson, we're going to do it a little bit quicker. Cosine c. We solve for cosine c. Now I can plug in everything I know. I'm going to put cosine c on the left just because it makes me feel more comfortable. And it's all about me. So it's 14 squared minus, these aren't both 11, this should be 9. 9 squared minus 11 squared all over negative 2 times 9 times 11. And if you do this, let's do it over because I'm not sure. Let's do this. 14 squared minus 9 squared, so 14 squared minus 9 squared minus 11 squared all over, oops, son of a gun. Let's hit enter. Divided by, and I'll put this in parentheses, you'll see this makes more sense, negative 2 times nine times 11 times 9 times 11. It'll turn into a nice fraction for me. That's what I should have had on top, but that's just this big mess. So I get 133. So I know the cosine of theta. Something's not right here. Oh, man, I used the wrong. Man, that's my problem. I used the wrong. I knew something was wrong. I used 17 instead of 14. I don't know why. The problem doesn't say 17. So cosine of c is equal to 1 over 33. So c equals, let's do the inverse cosine of this. So inverse cosine of, you can also hit the up arrow once and just hit enter and I'll retype it for you. 88.263. 88.263. So it's set to the nearest degree, so this would be 88. But remember, this is 88 degrees. So therefore, this must be 180 minus 88 degrees, or 92 degrees. There she is. That's all she wrote. I got some gorgeous work on my answer key, which is completely wrong, which is bothering me mostly. I think this is right. If you find a mistake, let me know. Put it in the comments and take my humble embarrassment. But at least I showed you how to do the problems. You should be okay for the test. They're not that difficult. Just draw it in and either use the law of cosines or the law of sines. Hope you all enjoyed my funky bunch. Maybe we'll end with a little bit. Oh, you know what? I might get bombed off of YouTube for having that on there. Oh, man. I'm going to not put it on there. We'll see. I might have to take it off. See ya.